This is not for everyone, but here's how I'm building a pocket-sized machine with the full power of PC. I'm building a Cyberdeck. For years, I have been finding smaller and smaller ways to use my computer. First, I used a thin and light laptop, then a tablet with a keyboard, and then a phone. But that's where everything falls apart. Because, yeah, phones are portable, tablets are portable, but you can't actually code on it. I want a real computer that I can throw into my backpack and still code everywhere. That's when Raspberry Pi came to mind. It's tiny, it's flexible, and most importantly, it's a real computer. I don't need insane compute power, but I do need real Linux. I want full control and a good battery life. So that's where I am building this Cyberdeck based on Raspberry Pi 2.0. It has a quad-core processor, built-in Wi-Fi, runs pure Linux. Heck, you can run Minecraft on it, and you can do whatever on this machine. It's very small and it's really efficient. That's what I need. So here's the thing: coding on a tiny screen? No thanks. I want to use a big screen, so I'm going to put in a 5-inch display, big enough to write code, and small enough to stay portable. And for the keyboard, I'm not designing any complicated thing. I'm just going to use off-the-shelf TV remote that has a full QWERTY style keyboard, and it has a USB dongle to work with Bluetooth. So there's no custom hardware, nothing sort of like that. Anyone who's watching this video can make this at home. Same for battery life. I could design a custom power management board, but that means soldering and other things. Instead, I'm using a 5000 mAh power bank. It's small, it runs for more than 4 hours, and it's easy to replace. It requires zero custom electronics, and you can easily recreate it at home. So now that hardware specs are done, we can move to prototyping. After many prototypes and many 3D prints, I finally have a version that I'm actually happy with. So let's assemble everything. So first, let's put the screen. Then I have placed a wire here, which is connected to a on-off switch. I need to place it there. Then I have this cable which I'll connect to power on the screen as well as the Raspberry Pi. And it's a really tight fit, but that's okay. We can plug in the dongle to our Raspberry Pi. It will control the keyboard, and then we can place it directly into this, and we can put in our power bank. This is standard power bank, you can remove it anytime, and it will give you plenty of power. It will run about 4 hours. And we have a clear plastic bag that can be placed by sliding it in, so that's fine. I have not designed it fully, so it's half broken, but I will replace it in future editions. Okay, time to put in a keyboard. So this is the broken keyboard that I have. I'll just place it inside of the case, and this also has a sliding door, so basically you can slide in its top and it will be secured in. Time to open it. It will boot into normal Linux, as this is just a Raspberry Pi. I can clear the screen and type nano hello world.py. I can type in print hello world. It's already there. Sorry if the screen is not visible, but once I have typed it, I can write python hello world.py and it will show us hello world. Let's see. Ah, it works. Okay, that's done. So I think I've made a quite good machine here, and it definitely needs some improvement for the future version, but I'm really happy with it. I can use it anywhere I want. I use it in bus, during my commute, every time I'm just outside, and I don't want to use Instagram. And I think in the future versions I will make the build quality better and add some support so that the ports are there, and I will provide the 3D file so that anyone can build this on their own also. And see you around.